Hello and welcome. In this video, we're going to be classifying systems of linear equations. So let's say I start with a line, and suppose it just goes like that. So remember what that line represents. That line represents all of the solutions to a given equation. So if I pick any point on that line, I find its x and y coordinates, those would be solutions to the equation that graph represents. Okay, so when we're talking about systems of linear equations, we're talking about more than one line. So in particular, at least in this video, we're going to be talking about two lines. So if I draw two lines on the same grid, really three things can happen. So if this is my first graph, maybe the second graph that I draw does something like this. One of the things you'll notice is that those two lines cross. And where they cross, that's what we call a solution point to the system. It's a common solution to both equations. So in this particular instance, we have one solution. And this type of system is called consistent, independent. Okay, what's a second thing that can happen? Well, a second thing that can happen is that the lines don't cross at all. So maybe my first line looks like this, and then my second line, well, if it's not going to cross the first one, then it would have to run parallel to that first one. So if the lines don't have a common solution point, we call that inconsistent. Okay, and then note again, there are no solutions to that system. Okay, well, can you think of a way to draw two lines on the same grid, straight lines, where they cross in more than one point? It's a little bit confusing, but there is a case where that happens. So the third case is exactly that. So let's say my first line, the first graph of my line does this. Well, the second graph of my line, if it's going to cross that first one or touch it in more than one place, it actually has to be exactly the same line right on top of the first one. So that was supposed to go right over the top of the first one so that you couldn't even discern between the two lines. So if the two lines are right on top of each other, we call that kind of a system consistent dependent. And in a consistent dependent solution, well, there are many common solutions. Basically, every point on the line is going to be a common solution to both lines. So there's actually going to be an infinite number of common solutions. So what we say is there's an infinite number of solutions.